This experiment often leaves people puzzled. Some think it's just a trick. Others believe the lighter's flame is what turns the lamp on.
In this video, I'll walk you through a step by step what's really happening. No tricks, no hidden power, just physics in action.
Here's a simple neon lamp, the same type you find inside voltage testers. It's connected directly to a capacitor that's been charged with DC voltage. There's no power supply connected anymore. The capacitor is charged to a voltage within the lamp's stable discharge range, typically between 50 and 80 volts. Right now, the capacitor is full. The lamp is connected, but nothing happens. The energy is there, but the discharge path isn't active. At first glance, it looks like the flame is the reason. So let's test that. I light the kitchen lighter and slowly move the flame toward the lamp, only the flame moving through the air. Still nothing happens.
If heat or light from the flame were the cause, the lamp should turn on here, but it doesn't. So we can rule out two common explanations. First, heat. The flame is close, but the lamp stays off. Second, light. The flame's glow is right next to the lamp, and the lamp is still off.
So what's left? Yes, you guessed it. The spark. Now I block the flame with tape. No flame, only the spark. And yes, the lamp turns on. A neon lamp requires a breakdown voltage to ignite. In this experiment, the lamp is connected to an energy storage capacitor. Between the lighter's spark and the lamp electrodes, there's always a small parasitic capacitance formed through the air and the glass envelope. The spark produces a sharp high voltage pulse with a very large rate of change. That rapid voltage change couples through the storage capacitance and injects a short displacement current into the lamp electrodes. The sharper the pulse or the larger the coupling capacitance, the stronger this injection becomes. This brief pulse momentarily changes the electrical condition inside the lamp and allows gas breakdown to begin. From that point on, the spark no longer supplies energy. The discharge is sustained entirely by the energy already stored in the capacitor. So what role did the flame play? Physically none. It's not an energy source, and it's not the main cause. But visually, it misleads us and pushes our brains toward the wrong explanation. As the capacitor discharges, its voltage gradually falls below the lamp's sustaining voltage, and the lamp turns off. This sustaining voltage varies between lamps, typically from 40 to 75 volts. After that, another trigger won't work until the capacitor is recharged.
This experiment is not a trick, and it isn't energy transfer through the air. It's simply an example of how in physics energy can be present but unusable until the right conditions are met. The lamp doesn't turn on because of fire or because of the flame's light. The spark doesn't provide energy, it only unlocks the stored energy.
What really matters is the discharge condition, not the spark itself. Sometimes having energy isn't enough. The conditions must be right. And there's another regime. If the voltage is raised above the stable discharge range, the neon lamp won't glow orange. It will only flash briefly. That's a different physical process, and we'll explore it in a separate video.